So we talked about solving logs in the calculator. Now our calculator only does common logs, so it only does log base 10 of the number, where it doesn't even put the base in the calculator, it just says log, and it gives you the parentheses, put it in. We're going to talk about the change of base formula, which you've seen before, but in case you forgot. The change of base formula, we do log of 25, so the log of the big number over the log of the base, so log of 4 would go on the bottom. So base is the bottom. So then we're going to put this in the calculator. You can totally put this all in the calculator at once. You just have to be careful with the parentheses. When you put log in the calculator, it's going to give you a parentheses. So then put 25. Make sure you close the parentheses before you click divided by, and then you want to do log of 4. So you have to close the parentheses on the first one before you divide by log of 4. If you want to do it separately, you could do it too. So we have 2.3219. We look at the fourth decimal to tell us how to round to the second. So if our fourth one's 9, do we round up or keep it the same? All right, let's do B. So what would go on top? Log of 12 over log of 2. The base goes on the bottom. So in the calculator, I'm going to do log of 12, close the parentheses, and divide it by log of 2. So you don't have to. If you want to, just to be super sure, you could put the top in parentheses, then divide it by the bottom in parentheses. You can do it that way too. Or you could do it separately. Find the log of 12, get a number, divide it by the log of 2. So either way works. So we get 3.5849. 9 tells us that we round up, so that would make this 3.585. All right, you can do the same thing with LNs. So we could do ln of 25 over ln of 4. We'll get the same answer that we did before. So you'll get 2.322. Same thing with the log. You can do ln of 12 over ln of 2. You'll get 3.585. So you can do it either way. You can do the logs or ln's. You just have to be consistent with it. You can use logs or you could use ln's as long as you're consistent. So you just have to be using the same one in the same problem. But you'll end up with the same answer. You can do it both in your calculator. You'll see you'll get the same answer. Next, we're going to talk about properties of logs. So we're going to be expanding and condensing logs. When we expand, every time we break it apart, each one is going to get its own log with that base. So if I had log base A of u times v, when we break it apart, each one's going to get its own log base A. Now when we're multiplying, multiplication goes with addition. When we're dividing, division goes with subtraction. So we could break it apart by subtracting. And then if we have an exponent, the exponent is going to turn into a coefficient when we are expanding. Now, all of these properties work both ways. So we're going to be expanding and condensing to a single log. So when we are adding, to condense it, we would multiply. So same thing, they go together. And then same rules apply for when we have ln's. So log and ln's are same properties. We're going to skip example 3. These you can just put in your calculator if you see some on WebAssign. Skip. So example 5, we want to use the properties of logs to expand each expression. So when I expand, I'm multiplying the 5 to the x to the third power and the y. So what goes with multiplication? Addition. So I'm going to break these apart, and each one is going to get its own log. So log base 4 of 5 plus log base 4 of x to the third power plus log base 4 of y. So then one more step that we have to do, any exponent that we see, we want to turn it into a coefficient. So we've got log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. So every time we break it apart, each term is going to get its own log. And we're going to end up with, bless you, log of just one term. So if you're still multiplying like 5x, you still need to break that apart. Let's do B. So here we're dividing. What goes with division? Subtraction. So I'd say ln of the square root of 3x minus 5 minus the ln of 7. Now here we can actually simplify a little bit more. How would I write the square root as an exponent? One half. The square root is the same thing as saying the 1/2 power. And what do we do with an exponent? We move it to the front. So I'm going to move that 1/2 to be a coefficient in front. So we have 1/2 times the ln of 3x minus 5 minus the ln of 7. Now this 3x minus 5 is in parentheses, so it's kind of just like one term. We can't break it apart. So this would be as simplified as we can go. This is expanded here. So in example 6, we're going to be condensing it down to a single log. So first thing we want to see, any coefficients we have, we want to put those up top and make them exponents. So I have the 1/2 power. I'm going to put that on top of the term that I'm taking the log of there. So it just goes on the x. And then the 3 is going to go on the x plus 1. And then when we're adding, how do we condense it? What goes with addition? Multiplication, perfect. So I have the log base 10 of x to the 1/2 power times x plus 1 to the power of 3. You could leave it like this, or we could simplify. How else could we write x to the 1/2 power? Square root of x. So this would be log base 10 of the square root of x times x plus 1 to the 3rd power. So this would be our answer. We're condensing it down just to a single log.
Isn't there an exponent where you're supposed to move it?
That's where this 3 came from. Because here we're moving it, the coefficient, we're moving it up top. If there's an exponent, when we expand, we move it to the front. All right, let's do the same thing for B. So B, we're subtracting. What goes with subtraction? Division. And then any coefficient, we want to put it on top of the parentheses. All right, so we have ln of, up top, we're going to put x plus 2 squared. And then we're dividing by x. So the x just goes on the bottom. Now we're condensing it down to a single ln, so we get rid of the other ln when we divide. So when you're condensing it, you're just going to be left with a single log or a single ln. Any questions here? Bless you. For C, let's do inside the parentheses first. So we're adding, what goes with addition? Multiplication. So we have the log base 2 of x times x minus 4. And then this is times 1/3. What do we do with the coefficient? Make it an exponent. But this coefficient is being applied to both of these things. How would I write, if I put 1/3 up here, how else could I write the 1/3 power? It would be the cubed root. Perfect. So we have the log base 2. Now in the cubed root, since it's being applied to the x and the x minus 4, they're both going to go into our cubed root here. So the cubed root of x times x minus 4. Now a common one that you will probably see on the homework that really stumps people. Let's say we had log base 2 of x minus log base 2 of y minus log base 2 of z. So I'll call this D. What goes with subtraction? Division. Now, every log that's negative is going to go in the denominator for our division. So if it's positive, it goes up top in the numerator. So I have log base 2. The log that's attached to the x is positive, so x is going to go up top. And then in the bottom, we have y and z. So because these are both negative, they're both going to go in the denominator. So y and z. So this would be our answer. And then keep this in mind that it goes the same when you're expanding. Anything that's in the denominator, when you break it apart, they're both going to get a negative. So people will think that like, oh, we're multiplying y times z in the denominator, so they'll put like a plus to the z. But since they're both in the denominator, they both get a minus when you're expanding. Next, we're going to be solving logs. So logs and exponential functions. We did this in 3.1 and 3.2, where if we can make them have the same base, we want to give them the same base, because if the bases are the same, we can cancel and set the exponents equal to each other. Same thing, if I can make it a log equals a log, the logs cancel, and we can set what we're taking the log of equal to each other. Same for ln's. The ln's cancel. Just set what you're taking the ln of equal to each other. D is the same. Now for E, F, G, and H, here we're going to solve using the inverse. So if x is in our exponent, to get it out of the exponent, we have to use logs. So the one log that'll get rid of an e is going to be the ln. So if we had an e to the power of x, where x is in the exponent, we're going to take the ln of both sides. ln of e will cancel, and we're left with x equals ln of 7. Same thing applies. If we had an ln, we use e's to cancel it out. So I would make my big base e here. So I'm going to raise everything in my equation as an exponent with the base of e. So e to the power of ln is going to cancel, and we're left with x equals e to the power of negative 3. Bless you. Same thing with logs, but we want to do whatever our base is. So here, I would make my big base 10. So I'm going to raise everything in my equation to be an exponent with the base of 10. 10 to the power of log base 10 would cancel, so we're left with x is equal to 10 to the power of negative 1. What's my base in h? 3, so I'd make the big base 3. This cancels, so we're left with x equals 3 to the power of 4. Now the other way that you could solve these is you can put them into exponential form. You'll end up with the same thing. If I start with the base of 3, 4 would be the exponent, it equals x. You're essentially writing it in exponential form. So let's do A. So we can't get the bases here to be the same, so we're going to use our inverse to solve. What do we know that'll cancel out the e? ln. So I'm going to take the ln of both sides. So what we do to one side, you have to do to the other. ln of e is going to cancel, so you have x equals the ln of 72. Here you can just put it in the calculator, the ln of 72. So we get x equals 4.2766. We look at the fourth one to round to the third decimal, so it'd round up to 7. So 4.277. Yes?
Is it outline like the values similar to E, like how it's a letter of the E actually equals like 2.7?
So log base E is the same as ln. It's just a special ln, or it's a special log, so it turns into ln. All right, next let's look at B. So when we're solving with exponents, we need to get the base with the exponent all by itself first. So I need to get this part all by itself first. So what do you think I'd need to do first? Divide by 3. So since 3 is being multiplied, we got to divide to move it to the other side. So we have 2 to the power of x equals, what's 42 divided by 3? 14. Now here, can we make the bases the same? No, I can't make 14 2 to some power. So we have to use our inverses to solve. So since x is in the exponent, I need to put it into log form in order to solve. So I'm going to take the log base 2 of both sides. Log base 2 of 2 cancels. We're left with x equals log base 2 of 14. So if you have an exponential question, you're going to use logs to solve, if you can't get them to have the same base. Now here, how can I put this into the calculator? I can't put log base 2 in the calculator, so what would I need to do?
Log those 12 in parentheses, and then divide it by log 14.
Well, the base goes on the bottom, so it'd be log of 14 up top over log of 2. Don't forget, if you put this all into the calculator at once, you got to close the parentheses up top. So log of 14, close the parentheses, divided by log of 2. So you should get 3.8073. 3 tells us that we keep it the same. So 3.807. So with example 3, we need to get the base with the exponent all by itself first. What should I do first here? Add 3. So 4 times e to the power of 2x equals 5. What should we do next? Divide by 4. So e to the power of 2x equals 5 over 4. Now how would I get rid of the e? ln, we're going to take the ln of both sides. So ln of e cancels. We have 2x equals the ln of 5 over 4. Now be careful here. We don't have a base. So we can just put this directly into the calculator. You could just say the ln of 5 divided by 4 and close the parentheses. So 2x equals, when I put this into the calculator, we get 0.22314. What should we do next? Divide by 2. So x equals 0.1115. 5 tells us round up or keep it the same. Round up. So 0.112. Let's go to the next page. Let's look at example 4. So same thing, I want to get the base with the exponent all by itself. What should I do first? Add 4. So 2 times 3 to the power of 2t minus 5 equals 15. What's next? Divide by 2. So 3 to the power of 2t minus 5 equals 15 over 2. If you want to put it in the calculator now and get a decimal, you can. You could leave it as 15 over 2. This is a nice decimal, so we can divide it. We get 7.5. What should we do next? Log with what base? Log base 3. So whatever the base is that has the exponent, we got to make the base of our log. So log base 3 of 3 cancels. We're left with 2t minus 5 equals log base 3 of 7.5. How would we put log base 3 of 7.5 in the calculator? Log of 7.5 over log of 3. Remember, the base goes on the bottom. So log of 7.5, close the parentheses, divided by log of 3. So that'll give you 1.83404. Now we're not done yet, so don't round yet. Don't round until your very final answer. What would we do next? Add 5. So 2t equals 6.83404. Again, keep it in your calculator. Don't round until the very end. What do we do next? Divide by 2. So chi equals 3.4170, which means that we'd keep it the same. So we're taking the ln of x, so we have an ln question. What do we need to do to get rid of the ln? We make the big base e. So I'm raising everything to the power, everything in my equation is going to become an exponent. Our base is e. E to the power of n, ln cancels. 3x equals e to the power of 2. Here we can put e to the power of 2 in the calculator, or if you want to do it all at once. What's the last step that we have to do? Divide by 3. So x equals, we'll do e to the power of 2. And then if you're going to do it all together, make sure you put e to the power of 2 equals or close the parenthesis. Because if you do e to the power of 2 and then divide by 3, it's going to think that you're doing e to the power of 2 over 3. So just be careful. So e to the power of 2 equals, and then divide by 3. You should get 2.463. Any questions here? All right, B. What do we do when we have a log equals a log? Cancel them and set whatever we're taking the log of equal to each other. So 5x minus 1 equals x plus 7. What should we do next? Subtract the x. We're just going to solve this normally. Subtract the x, and we can add the 1. So 4x equals 8. Then what? Divide by 2. X equals 4. Now, when we have log equations, there's one thing that we have to keep in mind. We cannot take the log of 0 or a negative number. I did. I was going too fast. We need to divide by 4. And our answers too. There we go. All right, so when we're solving log equations, you cannot take the log of 0 or a negative number. So whenever you have log equations, it's going to be helpful just to check your work. So you don't have to work it out all the way when you check, but just kind of lightly plug it in. Make sure you're not taking the log of a negative. Here, if I plugged in 2, 5 times 2 would be what? And 10 minus 1? 9. Is 9 a negative number or 0? No, so it's good there. And then here, if I plugged in 2, 2 plus 7 is 9. Is 9 a negative number? No, so we're good there. Sometimes when you're working out these equations, usually when you have 2 answers, you might have one that doesn't work. You might have an extraneous solution. So with log questions, you always just want to kind of lightly check by plugging it in. Make sure that you don't get a negative. All right, example 7. What do you think we have to do first here? We got to subtract the 5 first. So here we need the ln to be all by itself before we can cancel it out. So we have to subtract the 5, move it over. We have 2 times ln of x equals negative 1. What should we do next? Divide by 2. So ln of x equals negative 1/2. What do we do next? Make the big base e. So we're going to make the big base e on both sides. It'll cancel out with the ln. So x is equal to e to the power of negative 1/2. Then we can just put this into our calculator. So e to the power of negative 1 divided by 2, and then close the parentheses. I would recommend putting this into parentheses. So it gives you the start of the parentheses, just close the parentheses. So we get x equals 0.6065. 5 tells us we round up, so that would make the 6 a 7. Let's look at number 8. What should we do first? Divide by 2. Since 2 is being multiplied by the log, we want to divide by 2, move it to the other side. So log base 5 of 3x equals 4 over 2, which would be 2. What should we do next? How do I get rid of the log? Make our big base 5. So whatever the base of our log is, that's what our big base has to be. So 5 to the power of log base 5 is going to cancel. So 3x equals 5 squared. So 3x would equal 25. And then divide by 3. So x equals 25 over 3 if we wanted to put it into the calculator. We get 8.333. Questions here? Awesome. Let's do number 9. So with number 9, we can't just cancel out all the logs. It does not work that way. People will do that on the test anyways and get it wrong. So you can't just cancel out all the logs. It only works if you have one log equals one log, or one ln equals another ln. But how could I condense these to be a single ln? We're going to multiply. Since we're adding, we're going to condense them with multiplication. So we have the ln of x minus 2 times 2x minus 3 equals, how could I condense the right side? Could I move that coefficient? What would I do with it? Make it an exponent. So the ln of x squared. Now that we have an ln equals an ln, we can cancel them out and set whatever we're taking the ln of equal to each other. So we have x minus 2 times 2x minus 3 equals x squared. What would we need to do here to solve? We're going to FOIL. So here we get 2x squared minus 3x minus 4x plus 6 equals x squared. What should we do next? Combine like terms. I'm going to subtract the x squared to move it over. So we get x squared minus 7x plus 6 equals 0. And what should we do next? Factor. What are two factors of 6 that add to negative 7? Negative 6 and negative 1. Perfect. So we get x minus 6 and x minus 1 equals 0. What would x equal? Positive 6 and positive 1. Now we have to check. So we have a log question. We have to check. So if I plug in 6, now we don't have to work it out all the way. You can just lightly plug it in. 6 minus 2, is that more than 0? Yeah, so we're good there. 2 times 6 would be 12. 12 minus 3, is that more than 0? Yep, so it's good there. And then if I plug in 6 here, the ln of 6, we can do that. That's more than 0. So 6 works. Let's plug in 1 and see if 1 works. So 1 minus 2, negative 1. Could I take the ln of negative 1? No, you can't take the ln or log of a negative. So 1 does not work. 1 is an extraneous solution. So you have to check whenever you have a log or an ln question. Usually when you end up with 2 answers, one of them's not going to work. It could be possible that both work, so don't think that that's always the case that one doesn't work. But just keep that in mind. Any log or ln question, just lightly plug it in. You can plug it into your head and see, does it work? Remember, it can't be negative and it can't be 0. And to just confirm that, if you're taking a test in your calculator, do the ln of 0. What do you get? What do you get when you put ln of 0 in your calculator? Domain error. It does not work. Take the ln of negative 1 in your calculator. Does not work. So you can't take the log or ln of 0 or negative.